Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this form of palindrome problem of the GFG. So guys, in this problem we are given a string and we have to find out the minimum number of characters we need to insert it, or we can say we need to add in this particular string so that this string will become a palindrome. Now what is a palindrome? A palindrome is a simple string. If we read this string from left to right or from right to left, then it will become same manner like a b a. Like if you read it, it will aba. If you read it here, aba. Okay, so it is the string where v sorry si is equal to s n minus I minus 1. The first character is equal to first character, second character is equal to first is equal to last character, second character is equal to second last character, and so on. Okay, this is what we call a palindrome is. Like here BAB, ABA is palindrome, and number of insertion required is 0 because our string is already a palindrome. Okay, AA is a palindrome, but here like for this given example ABCD, our string is not a palindrome. Our string A B C D is not a palindrome. So how can we make a palindrome? Here you can see the maximum length of a palindrome is this A, as a single character is always a palindrome. uh, these four characters are simply a palindromic string in its own. Like this is a palindromic string, so what we can do, we can add C B A here. This is one choice. As well other can what do, like A B C D, and he can add D C A and B here. B here. This can also be a palindromic string. Okay, but you can add X here. But why we will not do this? We will not add D two times because we have to find out the minimum number of characters. Okay, so we will not add the character. Like if we don't add a D here, then also our work is complete. Our string is palindrome. If we don't add X, then our string is also complete and became palindrome in just three insertion. Okay, so here we can make a string a palindrome like this. So and here aba is it is still a palindrome, so answer is equal to 0. Now how we will find out how many minimum number of operation we have to do? So for this what we can do, we will find out our longest palindromic substring. uh, what our longest in a string ab, suppose this is ca, this is cba, suppose for a minute. Okay, find out this is our given string. Then if we find out the longest palindromic subsequence of this particular string, then how can we approach the problem? We know the size of this string is n, or the length of this string is n, and our longest palindromic string is, suppose this is our palindromic string, this is a complete string, and these three part of this middle part is a palindromic string. Okay, suppose, and here c will not come in our palindromic. Suppose it has length is equal to x. Okay, so we have a string of size n and we have a palindromic subsequence of size x in it. So we can say in our n characters we have a string of x which is palindrome already. So how many characters we have extra? So extra character are n minus x, n minus x. So what if we add just n minus x character and we make a string palindrome? I am telling you with the example, like suppose a b x. Suppose this is our given string. Suppose this is our given string. Okay. Now here of length 4. Now LPS, longest palindromic subsequence. Longest palindromic subsequence is a b a, or you can say a x a. AA is also a palindromic sequence, but it is not longest. So here we will take AB or AXA. Length is equal to 3. Its length is equal to 3. Okay. So now n minus x is equal to n minus x is equal to 4 minus 3 is equal to 1. This is our n, this is our x. 4 minus 3 is equal to 1. So we need to insert just one character in it. So how can our string will look like? This is a b x a. So if we take axa as a palindromic sequence, then what we can do, we can add b here. Or if we are taking aba as our answer, means aba as a string, then what we can do, a b, a is our string, here one extra x is covered, so we can add a x here. So either we can add a b here or we can add a x here, but in both cases we are adding just one single character. Means from n we have a size, we have x character which make a subsequence which is palindrome. So if we subtract this n, this x from n, then these are n minus x are our extra character which is not fit in our palindrome. So what if we add these n minus x character in our palindrome in our string extra, then I can make my string n complete palindromic by adding n minus x character more. So this n minus x will be our answer. This is the basic approach of this problem. So now the problem is how we will found the longest palindromic subsequence. So there is two ways how you can find it. First is LPS. Now what is LPS? It is longest common subsequence, lowest, longest, okay, longest common subsequence of string s and reverse of string s. Reverse of string s. This is longest common subsequence of string s. Either this is first method, and the second one is that I will use, it is pure DP with just a single string. In this you will need space n square plus an extra space. Okay, this as a space is as it is, but we need n square plus an extra space because we will store a reverse string and we will need n square DP array for finding longest common subsequence of string s and reverse s. Okay, now we can use longest palindromic subsequence just using only a single act as well, but this is just some complicated. Okay, this is somehow complicated. If you do matrix and multiplication problem, it is something like that. So here we just need n square memory and time complexity in both are same. And complexity in both are same. It here it is for this case it is n square plus n log n, n log n for sorting the string, but here n square will dominate over n log n. So here it is equal to n log n square, here it is equal to n square, and in second case, it is purely n square. Okay, so it is basically n square plus n log x for sorting the string, but it will ignore, we will ignore it because n square is a very large, and square is very large account, will make a large portion in n square plus n log n, so we can ignore n log n. Okay, and here it is purely n log n. So this is perfect method, but this is easiest way. Now I will not going to tell you LCS as it is very common. I just tell you the way you can find the LCS of s and reverse of s, or if you want how why this is, then you can try run for a case. Okay, like this is a string which is same as this is s1, this is as a string, named it as s1, it is s2, it is reverse of s, it is reverse of s. And if here some palindromic string, suppose here b c b string exists, then also here this become here, this become here, this become here. Okay, so the all the palindromic part this string has, this string will also come that in same order, because a palindromic subsequence are same in both order from left to right or right to left. Okay, so bcb will remain bcb. So like, and here is some string, here is some string that is non-palindrome, here is x, here is x, suppose, then this string will come here, then a string will come here, this x will come here, this is x, this is x. Okay, So here the longest common subsequence will be the palindromic subsequence, because in palindromic subsequence you will go to the same in reverse or in simple manner from starting or ending. Okay, so that's why it is work. If you want to need more info about it, then you can try run it or check out striver video on it. Striver make a complete full-fledged video on it for longest palindromic subsequence. And if you want out this is somehow complicated method. Okay, this is this factor in DPDP. Then for each tenth, we will turn a loop. Like this is the code. I am telling you the code. This is very simple code. But if you want to know how this second method is work, how this is work, then you can check out this video of pap coding. Longest palindromic subsequence, dynamic programming, explained code video of pap coding. Here is the code. Okay. This is very good video and you will completely know how longest palindromic subsequence will work out. Okay, here he will tell you, here he will tell you how it will work completely. And here is the code. I write this code just by hearing the video, because this video is very good for this perfect concept. And then what you can see, here dp0 and -1 will store the maximum palindromic subsequence, or you can say the tenth of longest palindromic subsequence. And if we subtract it with n, here you can say dp0 and -1 is our x. So, and I told you n minus x is our answer. So here we just written n minus x. Now I am trying it. Here answer is completely good. I am submitting it. So you can see all the 70 test cases pass out. Time complexity is 0 0.0. If you do it by LCS, then it is someone 0.56 nearly about. I am assuming. Okay. So here this is my personal attempt. Okay, so here all the 70 test cases pass out. I hope you will understand it. And for this, here is the code. This is the easiest code, I think. You can check this code as well. I am completely show you the code, but I am not explaining you, because if I explain you, and then you will not understand what I want to say. Because here you can see this is 41 minutes long video, so at least see 15 or 20 minutes, then try to do the code, write the code as your own, as I did. Okay, then you will understand this is simple code, but in writing you will see it's complex. It is complex, but as you write it, then it will become easier for you. Okay, so guys, I explain you. And if still you have any doubt, then just comment out. I will try my best to explain you. And for now, you can like the video, subscribe the channel, and check out my channel for more these type of videos. Thank you for watching this, guys.